Hi everyone, today we're going to be talking about section 6.4, which is on nth roots. Alright, so what are nth roots? Okay, well, any number that can be to the nth power is considered an nth root. So sometimes we think about like square roots, right? X to the second. And so its root would be the second root. And if we do x to the third, its power is 3, which is 3. So an example of a number would be 4 times 4 times 4. And we can use this to figure out what that root is. Okay, we call those cube roots right here. And I know we've kind of looked at some of them before in different assignments, right? And so like an example of a question you might have is x to the fourth is 625. So what value of x to the fourth power is 625? And so obviously you can see it's 5 to the fourth power is that. And so if we're going to go in vice versa order, right, the fourth root, right, would be right there, the fourth root of 625 is going to be 5, and so on and so forth. And so what we can talk about is nth roots of problems, okay, problems that we can do to the nth power, right? So, and we can do that all the time, right? We can figure out how many factors of it are going to be to some power. So the definition of an nth root is this: for any number a and b and any positive integer n, if a to the n equals b, then a is the nth root of b. So for example, negative 3 to the fourth power is 81, because negative 3 times negative 3 times negative 3 times negative 3 is going to equal a positive 81. Okay? And so we call 3, it's got a special name, we call that the principal root. Now, I don't use that terminology very often, but if you ever hear that, that's what they mean, is a principal root. Okay, so this is something that you might want to write down. Okay, if you're writing down your notes, this is something you probably want to put in. And plenty of times in class, when we've had stuff in class, I would make this something that you'd have to write down. Okay, we call this the index. Index is this n right here. The radicand is the name of that symbol, and or the radical sign, and then the radicand is what's underneath it, right? And again, we call those principal roots, right? Now, one thing that you'll notice, right, is if you have a positive, we normally don't put a plus sign here, but if you have a positive square root, your value is positive. If you have a negative, you get a negative 5, which is different than what we've kind of talked about when we talked about imaginary numbers and stuff like that. All right, and then we have plus minus. It could be plus minus 5 is our solution. Okay, so important information is this: if our power n is even, right? 2, 4, 6, 8, 10, right? And we have something that's greater than 0, right? There's one unique positive and one unique negative root. Okay, so right here, plus or minus, we could write it down. If it's less than 0, meaning it's negative, there's no real roots. That's where our imaginaries come in, right? Imaginary. And if it's equal to 0, then it's just 0. Okay, good to know, right? Now, if our n, okay, if our n is odd, 1, 3, 5, so on and so forth, there's one unique positive and no negative roots, right? There's no negative roots. So that's different from when it was even, right? And so we have just that, right? If we have a negative number, notice there's no positive and there's one negative. So there is a solution when it's a negative number underneath the radical sign. And finally, the same thing, no matter what, the root of 0 is still going to be 0. All right, so let's look at some examples real quick. Okay, so I'm going to look at this one right here. Plus or minus the square root. Notice there's nothing here, so we can imagine it's a little ghosty 2 right there. Okay, but without that, we know what it is. Okay, so let's say we're doing plus or minus. So we know that our answer for sure is plus minus. That 2 means it's an even number, so our answer is going to be plus minus. And so really I'm going to look at what is the square root of 16. Well, hopefully you know that the square root of 16 is 4. And what's the square root of y to the 4th? Okay, well, think about it. This is y to the 4th, and then that square root would be divided by 2. And so 4 divided by 2 would just be y to the 2nd. So here's our answer, plus or minus 4 y to the second. All right, let's try letter B. Now we notice again there's a little ghosty 2 there. All right, we know it's negative, so our answer is negative, right? And so the nice thing is this right here is all to the 8th power. So what we can do is we can literally just do this. X to the second minus 6 to the 8 divided by 2. Well, you know what 8 divided by 2 is. It's 4. So our answer is going to be negative x squared minus 6 to the 4th power. That's our answer for letter B. Okay? Letter C. Okay? Letter C. Now we're looking at an odd root. It's 5, right? So what we're going to do is we're going to do 243 to the 5th power, or to the 1/5 power. Now, I don't exactly know what that is, okay? I don't know what that is off the top of my head. So what I'm going to do is I'm going to pull up decimals, okay? All right? So I pull up decimals, all right? And so what I can do with this is I can actually just type in, okay? I can type in 243. And then I can do to the 1/5 power, right? And that equals 3. Check it out. It says it right there. It equals 3. That's super awesome. That really helps us out a lot. So I know for sure that this is going to be 3, right? And then I have a to the 20. Well, if we think of that, a to the 20 divided by 5, that's going to be a to the 4th power. And then the last part is going to be 25, so b to the 25 divided by 5 is just going to be b to the 5th. So there's our answer right there. Okay? 3, a to the 4th, b to the 5th. Hopefully that's not too difficult for you. Okay? Now, the next one we're going to go to. All right? Check it out. We have negative 16 under a square root. Now, we said that there's no real roots, right? But we do know that there are imaginary roots. And so we're going to have to use i's here. So this is going to be 4i to start, because I know the square root of negative 16 is 4i. Then I look at x squared, so that's, or x to the 4th divided by 2. That's going to be x squared. And then I have y to the 8th, be y to the 8th divided by 2. So that would be y to the 4th. And there's our answer again. So notice I still do have some i's. I still do have i's coming up, okay? All right, here is 2 problems that I'm going to have you try on your own. So now example 2 is simplifying with what are called absolute values, right? And so what that means is you'll notice in here, right? You'll notice in here that I'm just going to take the 4th root of y to the 4th, right? So y to the 4 divided by 4, okay, is going to just be y. Now, it says to use absolute values. Now, I don't always believe in using absolute values because I mean, the reason behind it is we do the absolute value of y because then if it's negative on the inside, remember, that would really be an I. We talked about that before. So I'm going to give this up to you, okay? Now, if you're taking an ACT test, you're taking an MCA test, they don't use absolute values. So their solution to this is just going to be y. Now, if you wrote this, or let's say you looked it up online, or you're using some sort of technology and it gives you an absolute value, use it. That's fine. No big deal. But if you just wrote y, that's totally cool with me. All right, and we can do the same here to the 6th power. So I don't know what 64 to the 1/6 power is. So what I'm going to do is I'm going to pull up decimals real quick, and I'm just going to figure out what that is, right? So I'm going to say 64 to the 1/3 power is 4, okay? So we take 4, and okay, so I know that that's going to be 4. And then, see, this is 18 over 6, right? So this is really x squared minus 3 to the 18 divided by 6 power. That's going to be x squared minus 3 to the 3rd power, right? Okay, where the absolute value would come into play would be this part right here. Because obviously we know that 4, okay, this 64 is positive, it's not negative, but we don't know that this is specifically positive. Again, so if you were to look it up online, it would probably look like this. And again, my personal preference is to not use absolute values, okay? So in the guided practice problems down here, okay, I'll probably use absolute values so you can use it, but so you get in the habit of using it. But if you don't, it's no big deal, okay? All right, so now we're going to approximate some, Okay, so the problem is um, it says c is equal to the fifth root of b squared. Represents the number of collisions, and b represents the number of bicycle riders per intersection. Estimate the number of collisions at an intersection that has 1,000 bicycle riders per week. So what that's saying is that b is equal to 1,000, right? Okay, so what we're asked to do is let b be 1,000 in this problem. So we're going to say c is equal to the fifth root of 1,000 squared, right? And so a couple different ways we could do it. First way I could do it is to do this. I'll say it's the fifth root of, okay, 1,000 to the second power is going to be 1 with 3 times 3 with, or excuse me, 6 zeros, right? That's what 1,000 times 1,000 is. It's going to be 1,000,000, right? And so then we take the fifth root of that, okay? So again, I can go to Desmos, right? And I can go and I can say, all right, well, 1,000,000, 2, 3, 4, 6 to the power of 1/5 is going to be this number right here, 15.8, blah, 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 right? And we could write that down as our answer, right? We would say that it's equal to 15.8, whatever, okay? We can do that. The other way I could do it, okay, and this is, again, personal preference. The other way I could do it is do this. I could have said that this is really equal to, actually, I'll write it like this instead. Okay, I could actually write this as 1,000 to the 2/5 power, right? That's another option right there. And again, you'll notice if I was to put this in my calculator, in fact, we will just for checking it out, right? We can actually do this. We can say 1,000 to the 2/5 power. Notice it's the same thing, 15.84, blah, 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 right? It doesn't really matter which way I do it. Both are going to give you the right answer, right? And so you get, that's your own personal preference. You get to choose, okay? So right there. So if it says how many collisions are going to happen at this intersection, approximately 15 to 16 collisions will happen if there's 1,000 bike riders in a week. All right. So here's part two. If the total number of collisions reported in 1 week is 21, estimate the number of bike riders that pass through the intersection. So now they're telling us what C is. C is now 21, and our job is to find what B is, right? So let's do that, okay? So we're going to say that 21 is equal to the fifth root of b squared, okay? Now, again, there's two different ways you can do this, all right? You can do it this way, okay? You can do it this way. This is probably how I would do it, okay? Is I would take this, and how do I get rid of a fifth root? I put it to the fifth power. And I say, okay, well, what is 21 to the fifth power, right? Well, I go to Desmos, right? And I just say, all right, 21 to the fifth power is 4,084,101. So 4,084,121. Okay, and to make sure that number is correct. 101. That's why we double check our answers all the time, right? 4,084,101 is equal to, okay, so now that's going to be equal to b squared because that and that cancel each other out. So that's going to be equal to b squared. And then what I can do is I can square root, and I can square root both sides, and I find that b is equal to, okay, the square root of that. I can do it on Desmos, or I just did it on my calculator. You can check on Desmos. It's going to be 2020. 0.9. We can't have 0.9 of a rider, so actually, you know what we're going to do? We'll just round it up to the nearest rider, which would be 21. Okay? So 2021 bike riders. That's how I can do it if I did both steps at different times. Otherwise, the other way to do this would be to say, okay, well, 21 is equal to, and we have to the 1/5 and to the second. I can say that that's equal to b to the 2/5 power, right? And so how do I get rid of a fraction, right? How do I get rid of 2/5 and turn it into 1? Well, I multiply it by its reciprocal, right? And so here I'm doing two different parts. 2/5 and 5/2 turns into b to the 1 power. right? And so I get b is equal to, and it's the same thing. If you check it, in fact, we'll check it on decimals, 21 to the 5 halves power is, again, right there, 2021. So again, it doesn't matter which way you do it, both of them are going to give us the same answer, right? It doesn't matter which way you do it, you're going to get the same answer both ways, all right? So here's another example, okay? Talks about surface area and how to find volume. If you know the volume, how to find the surface area, and vice versa, okay? All right, so now you have an assignment. Good luck. Thanks for watching, and we'll see you in the Zoom session.